Okay. So hello everyone, welcome to MEMONEET. My name is Prachi and today we are going to solve the questions of part test 3. Okay. So in chemistry section A, the first question is identify the correct statement about the Lucas test. Okay. So what is a Lucas test? What is a Lucas reagent? Mainly it is Zn plus HCl. Okay. So let's read the statement. Lucas test is used to distinguish between first, second, and 3-degree alcohol. Yes, it is a true statement because Lucas test is used to distinguish between the types of alcohol, whether it is 1 degree, 2 degree, and 3 degree. So let's discuss one by one that what are the uh, reactions or what are the characteristics that we obtain in the types of alcohol. So for primary alcohol, which is the 1 degree, when we add the Lucas reagent, there will be no reaction. Okay, primary alcohol do not react with Lucas reagent. And in the secondary alcohol, what will be the, in the secondary alcohol, the turbidity appears after 5 to 10 minutes, and for 3 degree alcohols, the turbidity appears instantly. Okay, so these are the three statements. Okay, so first statement is correct that Lucas test is used to distinguish between 1 degree, 2 degree, and 3 degree alcohols. And I have also told that Lucas reagent is concentrated HCl and anhydrous ZnCl2. Okay, ZnCl2, here it is. This statement is also correct. Then the third statement is primary alcohols are insoluble in Lucas reagent. Okay, primary alcohols are insoluble in Lucas reagent. So this statement is not correct. Primary alcohols do not react with Lucas reagent. Okay, in normal conditions and are soluble. So it is not insoluble, it is soluble in Lucas reagent. The primary alcohols, 1 degree alcohols are soluble in Lucas reagent. So this statement is the incorrect one. See, it is incorrect in the question it is written. So this statement is the incorrect one. Okay, let's also read the fourth question. In the fourth statement. In the fourth statement, it is given that the tertiary alcohol produces turbidity immediately. Okay, so this statement is also correct. So automatically the third statement is the incorrect one and the correct answer to this question. Okay, so for second question in chemistry, which is the 52 one. So in 52, it is a correlated type question which is from GOC. Okay, so which of the following has the lowest pKa value? Okay, so we know that the stronger. Okay, so we know that pK. What is the formula of pK? Minus logarithm of Ka. Okay, this is the formula, and we also known as if the acid is stronger, the pKa value is lower. Okay, and also check one thing, the electron withdrawing group on the para position decreases electron density on the COH group. Okay, so for this we will look at the questions, look at the options. The electron withdrawing group decreases electron density, the electron density decreases. Okay, which makes the loss of proton easier. So let's apply the type of groups which are there in the options. So this part is common in all of the questions. Okay. So what is the difference here? OCH3 is there. Here no group is there. Here CH3 and NO2. So we know that OCH3 is the methoxy group, and it applies the plus R effect. So here plus R effect is applied. Here no group is there, and here CH3 applies the plus I effect and NO2 applies the minus R effect. Okay, so according to this, the acidity of 4, this minus R1 group, acidity is greater in option 4 because of minus R effect, which is the electron withdrawing group effect. So greater the electron withdrawing group, electron density will be lesser and the acidity will be greater. Okay, so accordingly, if the acidity is greater, the pK value will be lower. And in the question, it is given that the lowest pK value. So option 4 will be the correct answer. Okay, let's move on to question number 53. The half-life period of a radioactive substance is 69.3 minutes. 69.3 minutes. How much time will it be disintegrated? 80% of its original amount. Okay. Yeah. So in the question, what is given? The half-life period means the T half is given. T half it is 69.3 minutes. Right. In how much time will it be disintegrated? 80% of its original amount. Okay. So let the original amount be A. Okay. So what will be A? A will be 100 and 80% of it is disintegrated means used up. So A minus X will be 100 minus 80, which will be 20. Okay. So now let's move on to the question. So these are the given, we can say the given values in the question. So accordingly, we have to find the answer by putting it in the formula. So the formula for T half is 0.693 by K. Okay, so this is the formula. If we interchange this, then what it will become? K is equals to 0.693, which is the T half. Okay, so here this is the value of K. So let it be equation 1. So when we use the another equation, another formula, which is this one, T is equals to 2.303 by K log A minus X, A by A minus X. Okay. So let the T be here. We have to calculate the half lifetime. So this is the T half. Okay. The value of K, which we have calculated in equation 1, we will put in here 0.693 and the 69.3 will be upwards. Log A is 100 and A minus X is 100 minus 80, that is 20. Okay. So 100 by 20, it will be 5. So the value of log 5 is already given in the question. It is 0.7. So 0.7 is written here. And if we solve this, the answer comes out to be 61. Okay. So which option is correct among these four? 161 minutes. Okay. Yeah. So now let's move on to the next question. Okay. Which of the following reaction does not yield phosphine? Phosphine is PH3. Okay, it is the hydride of phosphorus. So let's read the option once. White phosphorus is heated with NaOH. Red phosphorus is heated with NaOH. Ca3P2 reacts with water and phosphorus trioxide is boiled with water. Okay, so let's see that which of the following reaction does not gives phosphine. Okay, so it is a theory type question. Red phosphorus does not react with sodium hydroxide to form phosphine. Okay, so it is a theory, you have to remember it. There's no other way to recall it or solve it. Okay, so it is type of theory question. So the answer red phosphorus. So red phosphorus does not give phosphine. So we have to find that which of these reaction does not yield phosphine. So second question will be the correct answer. But let's see other questions that if these reactions are giving the phosphine or not. Okay. So when white phosphorus reacts with caustic soda, see, P4 is the white phosphorus. When it reacts with NaOH and water, it will give sodium hypophosphite. Okay, NaH2PO2. It is the sodium hypophosphite and phosphine. So when white phosphorus is heated with NaOH, it gives the phosphine. So this will be the incorrect option. Ca3P2. Okay, Ca3P2 reacts with phosphine gas as one of the products. Okay, reacts with water to give phosphine gas. Okay, Ca3P2 plus 6H2O gives phosphine and calcium hydroxide. So Ca3P2 also reacts with water to give phosphine. And the fourth option is phosphorus trioxide. It also gives phosphine. So the second option is the correct option. Okay. So the next question is 55. A cell a cell reaction is given. Sorry. Okay, a cell reaction is given and E cell value is given, E naught cell value is given to be 1.10. Okay, was allowed to be completely discharged at 298 Kelvin. The relative concentration of Zn plus 2 to Cu plus 2, concentration of Zn plus 2 by concentration of Cu plus 2 is. Okay, so we have to find this one. So how we will find? Okay, so it is given that this cell is allowed to be completely discharged. What will be the meaning of completely discharged? It means that E cell value is equals to 0. Okay, so here the E cell value is 0. So now using the formula, E cell equals to E naught cell by 0.0592 log of Zn plus 2 concentration by log of Cu plus 2 concentration. Okay, so this is the formula. So we have taken or it is given the question that E cell is equals to 0. So E cell is equals to 0. We have to put E naught cell. It is also given that it is 1.10. Okay, so E naught cell is 1.10 minus 0.059 by 2. So here 2 is the N value. How we can find the N value? Zn to Zn plus 2 means the number of electrons that are involved in the reaction. So okay, so here 2 electrons is involved, and in the case of Cu also, Cu plus 2 electrons will give Cu solid. Okay, so here also 2 electrons are involved, so the value of N is 2. Therefore we have written 2 here, log of Zn plus 2 concentration and Cu plus 2 concentration. Okay, so what will happen? The negative side of the part will go to the left. Okay. So let me provide some space here. Yeah. Okay, so 0 is equals to uh, or here I can write 0 is equals to 1.1 minus 0.0592 by N log of concentration of Zn plus 2 by concentration of Cu plus 2. Okay, so this whole negative part will come towards the left side. which means that 0.0592 by n is 2. Okay, so log of Zn plus 2 by Cu plus 2 equals to 1.1. So let's transfer this to the right side now. So log of Zn plus 2 by Cu plus 2 concentration equals to 1.1 into 2 by 0.059. Okay. So on solving this, we will get 37.3, and upon transferring the log towards the right side of the equation, we will get 10 raised to power 37.3. Okay, or we can say that it is the anti-log. So according to this, the answer will be 10 to the power 37.3. Okay, so this is the 56th one. Okay, so sorry, 55th. Let's come to 56. Yeah. So in the 56th question, what it is given? What reagents are involved in the Gabriel synthesis method for producing amines? Okay. So let's write the Gabriel synthesis reaction first. It is also known as what? Gabriel thalamide synthesis, right? So let's draw it. Okay. So this is the thalamide. So in what happens in Gabriel reaction, Gabriel thalamide synthesis reaction, the thalamide is reacted with a strong base, let's say KOH. So we know that from a strong base, OH minus ions are released, which will react to the acidic hydrogen present in the thalamide reaction, and it leads to the formation of thalamide ion. Okay, yeah. And this K positive will react here, and yeah, it will form NK. Okay, so this is the thalamide ion. So after this, what will happen? Okay, so this is the thalamide ion, which on reaction with an amines, it is converted into an amine. Okay, this bond will be like this. So this is an amine. So this is the Gabriel thalamide synthesis reaction. So what reagents? What will be the reagents? It will be imide. Okay, because it is thalamide. Thalamide is imide. It is a type of imide. Let's move on to the next question. In question number 57, it is given that identify X and Y in the given reactions. CaC2 plus 2H2O will give X plus lime water. And when this X is reacted with water in the presence of H2SO4 and HDSO4, it will give Y. Okay. So let's work on this reaction. CaC2 plus 2H2O, what it will give? It will form an ethyne. Okay. ethyne and calcium hydroxide, which is the lime water. So this ethyne is the product A. So again when ethyne is, this is the ethyne, again when ethyne is reacted with water in the presence of H2SO4 plus HgSO4 at 60 degrees Celsius. Okay, this is given in the reaction. What it will form? It will form CH3CHO. CH3CHO. Okay, so this is the what this molecule is called. It is two carbons, and it is an aldehyde. So it is ethanol, and this is Y. Okay, and this is X. This is X. So which option is correct? Ethyne is C2H2. Okay, and it is ethanol, CH3CHO. So second option is correct. Okay. Okay, you have to make one correction in this answer or explanation. It is given formaldehyde. So formaldehyde will not be there. It is acid. It should be acetaldehyde. Okay, acetaldehyde. Yeah. So this is the correct option for 57. The next question is 58. So in 58, what it is given? Which of the following compounds exhibit tetrahedral geometry among the following options? So we have to draw all the four and find out which is the correct option for tetrahedral geometry. Okay, so let's find out. First one is NiCN whole 4 minus 2. Okay, so Ni is nickel. What is it? What is its atomic number? 28. Okay, and if we calculate its hybridization, then it is 4s2 3d 8. Okay, so let us draw. I need some space. Okay, let's rub it. Just a second. Okay, so we know that nickel has 4s2 3d8 configuration. Okay, and in the first question, nickel is present in +2 oxidation state, right? How it is +2? Because nickel, we have to find the oxidation state of nickel, and the oxidation state of cyanide is -1, and it is 4 molecules, and the overall charge is -2. So x minus 4 equals to -2, which means that x is +2. Okay, so nickel. So let's draw its ground state configuration first, which is 3D, 4s, and 4p. For nickel, it is 3d8. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, and 4s, it is 2 electrons. So now next we have to draw for nickel in +2 oxidation state. This is 3d, 4s, and 4p. In plus 2 oxidation state, the electrons in the s orbital has to be removed, so the d orbitals remains the same. Okay, 8. Now in the excited state we have to draw, like for NiCN whole 4 and minus 2. Here Ni is the strong field, sorry, Cn is the strong field ligand. Okay, so let's draw first. It is 3D, it is 4s, it is 4p. Okay, so for nickel, in what happens in a strong field ligand, the electrons paired up. Okay, so we have to pair up the electrons. So there are 8 electrons, right? So 1, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so now the CN ligands have to be fill up here. So the CN ligand will fill up here. CN, one CN molecule, second CN molecule, third CN molecule, and fourth CN molecules. Okay, there are 4 CN molecules. Therefore, what will be the hybridization here? It should be DsP2. Okay, and the geometry of DsP2 will be what? Square planar. Okay. Similarly, for PDCN6, it is also square planar geometry, as well as PDCl2, it is also square planar geometry. For NiCl whole 4 minus 2. So let's see this once. The nickel part will be same in the ground state. The Ni plus 2 is also same in the in the plus 2 oxidation state. What we have to do is change in the excited state only. Okay, so I'm going to write here only 2 minus. Okay, so we have to draw this. This is 3D, this is 4s, this is 4p. Okay, so Cl, here Cl is the weak field ligand. Okay, weak field ligands means the pairing energy is low. It means that it does not have the capacity to pair the electrons, like in the case we have done for Cn minus Cn. Cn is a strong field ligand, so it has a capacity to pair. Okay, so first draw the 8 electrons here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is, I am saying that it will not pair up the electrons. Okay, because it does not have the capacity, so the 2 electrons are left as it is. So where all the 4 chlorine electrons will be filled? Here, 1 Cl, 2 Cl, 3 Cl and 4 Cl. Therefore, it will have sp3 hybridization. So what is the meaning of sp3 hybridization? It will have tetrahedral geometry. Okay, yeah, so it will have tetrahedral geometry. So this is for 58. So let's move on to the next question. Yeah, okay, for 58 I have not discussed the answer, right? For 58 the correct answer is option 4. It will have tetrahedral geometry and the other will have the square planar one. Okay, yeah, for 59 what it is given? In the electrochemical cell, ZnSO4, its concentration is given 0.01 molar. For CuSO4, its concentration is given 1 molar. The EMF of the Daniell cell is E1. When the concentration of ZnSO4 is changed to 0.1 and the concentration of CuSO4 is changed to 0.01, the EMF changes to E2 from the following relationships. Which of the following relationship between E1 and E2 is there? Okay, so the relationship you have to find out between them. Okay, so this one is the numerical type question. So let's use the eraser and rub it. Yeah. Okay. So this is the question. ZnSO4. Okay. So from Zn to ZnSO4. ZnSO4. What does ZnSO4 means? It means that Zn plus 2 and SO4 2 minus. Okay. So this is the anode and the cathode is CuSO4, which means Cu plus 2 plus SO4 minus 2. It gives Cu. So this is the cathode. Okay. So in the cell, the concentration are given. Zn plus concentration is Zn plus 2 concentration is 0.01 and CuSO4 means Cu plus 2 concentration is 1 molar. Okay. So let's use this equation of E cell. E cell equals to E naught cell minus 2.303 RT by NF. You can use here 0.693 by N also. Okay, so what will be the value of N? N I have told it is the transfer of electrons, total transfer of electrons between the cell. So N will be 2. So let's put 2 here and the log Zn plus 2 and Cu plus 2. Okay, so E1 we have to take the first cell as E1. Okay, the EMF of this Daniel cell is E1. See here it is given E1. So let's take E1 equals to E naught cell minus 2.303 RT by 2 into F. Here it is given 2 into F. You can take this whole part as 0.693. Okay, or take it as like this also you can take. So Zn plus 2 concentration is 0.01, right? 0.01 and CuSO4 concentration means Cu plus 2 concentration is 1 is given. So this is the first equation E1. So it is given only in the question to interchange the concentration between the two cells. Like where Zn plus 2 cell is 0.01. So now let's take, okay, here it is log Zn plus 2 concentration by log Cu plus 2. Okay, like this. So upon interchanging Zn plus 2 becomes, see here it is given Zn plus 2 becomes 1 molar. Okay, so let's assume Zn plus 2 as 1 molar and Cu plus 2 as 0.01 molar. Again, take all this part as 0.693 by 2. So this is the E2. So upon seeing that, let's see, all of the thing is same except this part. Okay, so we can take like this. Okay, 1 by 100. So it is 1 by 100 and it is 100 by 1. So upon seeing this part only, which is greater 1 by 100. So this is small and this is greater 1. But let's not forget one thing, that the negative charge is there at the formula. Okay, so negative charge means this has to be lesser and this has to be greater. So it comes out to be E1 is greater than E2. Okay, so upon the following questions, which is the correct answer? E1 is greater than E2. So second one is the correct answer. Okay, so let's move on to the next question. Question number 60. In the following reaction A, C2H5 MgBr plus CH2 bond, okay, this is a type of compound. Okay, yeah. So what is the name of this compound? This is Grignard's reagent. Okay, this is the Grignard reagent. And we have to know that if it is a Grignard reagent, then MgBr, if we measure charges, then MgBr will have the positive charge and C2H5 will have the negative charge. Okay, so okay, and upon this oxygen will have the negative charge and this carbon will have the positive charge. So upon reaction with water, what will happen? This positive part will get attached to the oxygen which is of negative charge, and this negative part will get attached to the positive charged carbon. Okay, so what it will form? C2H5, CH2, CH2, OMG, Br. Okay, yeah. So upon reaction, this type of compound we will form. Hmm. So on workup means adding water. So we know that water also splits into two compounds, which is H plus and OH minus, and let's assume this part. So MgBr will always acquire the positive charge and oxygen will have the negative charge. Okay, so this OH negative will move towards the positively charged MgBr and this positively charged hydrogen will move towards the negatively charged oxygen. So what will be the case? What will be the answer? C2H5, CH2, CH2OH and MgBr OH. Yeah. So these two compounds will be formed. So upon seeing the options, which one is the correct one? 2 carbon, 3 carbon, 4 carbon. 2 carbon, 3 carbon, 4 carbon. So option 2 will be correct. Given for the reaction is given CH3 C double bond OH in the presence of N2H4 and OH minus gives the product A. Then it is again treated with bromine in the presence of H mu and it gives the product B. When again the product B is treated with aqueous KOH, the product C is obtained. Okay, so first we have to look upon the reaction. So let's see the reaction. Yeah. So when what is the CH3COOH? It is ethanol. Okay, it is an aldehyde. COH is CHO. Yeah, sorry. So when it is treated with N2H4, it gives ethane, and when it is treated with bromine, this type of structure is formed. Okay, and then after KOH is reacted, SN2 mechanism is followed, and then this type of product is formed. This is ethyl alcohol or ethanol, we can say. Okay, so we have to find out that this C product, which is the ethanol, gives which of the following test. Okay, so what is given? It is about Tollens test, Felling's test, and iodoform test. So let's see what is Tollens reagent. Tollens reagent is basically ammonical silver nitrate. Okay, yeah, ammonical silver nitrate, and B. The Felling's test. Felling's test, it mainly consists of two type of reagent A and B. A is aqueous copper sulfate and B is sodium potassium tartarate, right? Okay. So, and iodoform is the reaction with iodine and NaOH. So we have to see that the alcohol, okay, means that tolerance and swellings test only give test for the aldehyde group which is present. Okay, it does not give the test for alcohol. But here alcohol can give the iodoform test. So option C will be correct, that alcohol which is formed as the reaction C, the product C, it gives the iodoform test. Okay. For question number 62, for question number 62, for the reaction A plus B gives product. It is a table, it is given for A, B and C, the rates are given. So let's follow the order of the reaction. What is the formula for order of the reaction? R is equals to K, A to the power X and B to the power Y. So accordingly put all the values given here. R, the value of it is R, reaction rate. So in first equation we have find that this type of structure. In second one this, and in third one this, on putting the values in the equation. Okay. So now what we have to do, we have to equate these three equation. Okay, equate these three equation. First divide equation 1 by 3. First we have to divide equation 1 by 3 and then divide equation 2 and 3. Okay, so do these two things. After doing this, we will get the result as x is equals to 0 and y is equals to 2. Then easily we can find the overall order which comes out to be 2. So here, which is the correct option? Option 2 is the correct one. Okay. So next, the compound, this and this. These, what are these? So let's read first the options. Are geometrical isomer or structural isomer, exist together in dynamic equilibrium and contains the same number of sp3 sp2 carbon carbon bonds. Okay, so first try to write the molecular formula of these two structures. 1 2 3 4, there are 4 carbons, and count the hydrogens also. 3 4 5 6 7 8. So its molecular formula is this. The molecular formula of the 7 structural compound is 4 carbons are there, so C4, and hydrogen. How many hydrogens are there? 3, 4, 5, 6, 7, 8. Also 8. So these two have the same structural formula. It is clear now. So option 2 is correct. Let's move on to the next question. What statement about X is correct? Okay. So let's move here. Okay. So here P4 is white. P4, it is the white phosphorus, and in the presence of NaOH and inert medium of carbon dioxide gives the product X. Uh, what are the options? It is highly poisonous and has a smell like rotten fish. Its solution in water decompose in the presence of light. It is more basic than ammonia. It is less basic than ammonia. Okay. So in option number 60, in question number 64, we know that ammonia is more basic than phosphine because nitrogen is more electronegative. Okay. Here in the periodic table, nitrogen is here and below it is phosphorus, and we know that the electronegativity decreases down the group. So automatically nitrogen is more electronegative than phosphorus, which means that the lone pair of electrons on nitrogen in ammonia is more available to donate. Okay, means nitrogen have the more number of lone pairs, or we can say that the lone pairs of nitrogen are easily allowed to donate, which makes it a stronger base. Okay, so on comparing these two, the nitrogen is more basic and it can donate the lone pairs easily. So option 3 is correct, that NH3, nitrogen in NH3 is more basic. Okay, because it is more electronegative than phosphorus, or we can say phosphine. In question number 65, which of the following expressions correctly represent the molar conductivity? Okay, so for molar conductivity, we know that the conductance is Ka by I. Okay, so okay, wait. Which of the following expressions correctly represents the molar conductivity? So the molar conductivity of a solution is the conductance of volume V and containing 1 mole of electrolyte. Okay, so let's move here. Molar conductivity, we know that molar conductivity is Ka by I, where I is equals to 1 and A is equals to V. So the formula, which formula will be correct? Molar conductivity of M is equals to K by C. So here option 1 will be the correct one. Okay. For question number 66, which reagent is suitable for converting C2H5NH3 to C2H5Cl? So here nitrosyl chloride, NOCl is the correct option. It is used to convert the primary amines. Okay, so this is the primary amines 1 degree amine to chloroethane. Okay, alkyl chlorides we can say via nucleophilic substitution. It goes through nucleophilic substitution, and this is also a named reaction which is called the Hoffman's reagent. Okay, so for question number 67, what are the products which are obtained in the following reaction? This is chlorobenzene, and on reaction with magnesium and ETOH, it gives the product CX, and which on reaction with formaldehyde and H3O gives the product Y. Okay, so this is a reaction. Mg will react here and this type of structure will be formed, which again reaction with formaldehyde gives the primary alcohol. So this structure will be formed. So what is the option? Primary alcohol is the option. Option number 2. For question number 68, which of the following species are colorless? So for finding the color of the species, what we have to do, we have to find out the number of unpaired electrons. Okay, so for TiF2, see TiF2, sorry, TiF6 hold -2. Here the titanium is in the +4 state. Titanium in the +4 state means it has a D, 0 electronic configuration, which means that no D electrons, and no D electrons means that it is a colorless orbitals, because the electrons, if it does not go into d orbitals, which means that the compound is a colorless one. Okay, for COF6 whole 3 minus, it has 3 electrons, uh, 3 oxidation state, +3 oxidation state, and it has a d6 electrons, which makes it a partially filled d orbitals. Partially filled d orbitals, which means it can absorb the visible light and it is colored. For next compound Cu2Cl2, the Cu plus has D10 electrons and it has all the d orbitals filled. Similarly, NiCl whole 4 minus 2, it has 8 electrons. 8 electrons means this is partially filled. Okay, and it also is a colorless compound. So what is the correct option? The correct option is second, which is the TiF6 whole 2 and CuCl2. Okay, wait, what in the question it is given? CuCl2, right? Okay, for CuCl2, all the d orbitals have, okay. In CuCl2, all the d orbitals are filled, which makes the compound colorless. So either the d orbitals have to be completely filled for showing the colorless properties, or it has to be, it does not have to be any electrons. Okay. So in these two cases, the compound will be colorless. Okay, the next question. acetophenone can be converted into phenol by the reaction. So which reaction? See, it is acetophenone structure. And when reaction with MCPBA is a reagent, okay, which will do? It will form a complex like this, and then on reaction with NaOH, we form these two products. Okay, so acetophenone can be converted into phenol. This is the phenol by the reaction of MCPBA followed by base catalyst hydrolysis. NaOH is a base, so this reaction is the base catalyst hydrolysis, which yields in the formation of phenol. For question number 70, the correct order of reactivity for the addition reaction of the following carbonyl compounds with ethyl magnesium bromide. Ethyl magnesium bromide is C2H5 iodide, magnesium iodide. Okay, so what will happen? Correct order of reactivity is asked. Okay, so the reactivity of the compound depends on the steric factors, okay, as well as the electrophilicity, which means that, see, this is important only, steric hindrance increases. As the steric hindrance increases, the reactivity decreases. So we can see that here is one hydrogen, okay. Here is 2 CH3, here is one hydrogen and one CH3, and here the group is very large. CH3 whole 3 means that this carbon is attached to 3 CH3 molecules. Okay, so this is the most bulkier one. Fourth is the most bulkier one. So the steric hindrance will be greatest in 4. So let's write the order of steric hindrance first. For steric hindrance, the fourth one has the greatest steric hindrance. Okay, then 2 will have the second greatest steric hindrance because there are 2 CH3 groups, then option 3, then option 1. Okay, so steric hindrance is less, which means that which is more reactive. The first one is more reactive, the opposite order is followed for reactivity, which means that option 1 has the greatest reactivity, then 3, then 2, then 4. So this is the correct option. Okay, for question number 71, the time required to decompose a reactant up to 93.75% in first order reaction is. So write the first order formula. T is equals to 2.303 by K log 100 by 6.25. Okay, uh, required to decompose. Okay, so let's first take the A. A is the initial concentration, which is 100, and X is the 93.75%, which means that it is the concentration which is used up. So what will be A minus X? It will be 100 minus 93.75, which means that 6.25 is there. Okay, so now let's put T half is also given. Let's put all these value in the equation. So T is equals to 2.303 by K log of A by A minus X is there. So log of 100 by 6.25. Okay, so this will come out to be upon solving this. So log 16 is written as 4 log 2, and this type of reaction we will get. So for K we can write that okay. So for K we can write this type of formula, and on solving this the T half value is given. T half value is 3. So on solving this we will get 4 T half. Okay, and 4 into 3 is 12. So the option 12 will be the correct one. For question number 72, the correct order of the thermal stability of hydrogen halides. So what will be the thermal stability? So as the size increases, like from fluorine to iodine, we say, okay, fluorine has the least size and iodine has the greatest size, what happens? The bond length also increases. If the bond length between the atoms increase, what happens? That the bond strength decreases. Okay, so the bond length order, let's write the bond length order first. So the bond length increases, which means that HF will have the least bond length, then HCl, then HBr, then HI. This will be the order for bond length. So what will be the order for bond strength? It will be opposite, like HF will have the greatest bond strength, then HCl, then HBr, then HI. This is the order of bond strength. So as the bond strength increases, what happens? That thermal stability the thermal stability will also increase. Like the bond strength increases, the thermal stability will also increase. So what happens? That this is only the order of the thermal stability, which means that HF will be the greatest, HCl, HBr, then HI. So option 2 will be the correct one. For question number 73, what is the crystal field stabilization energy for high spin d octahedral complex? Okay, for octahedral complex, high spin. For octahedral complex, all the 4 electrons occupy the T2G orbitals. Okay, so this is the Eg and this is the T2G. So option for octahedral, the pairing energy will be lesser for low spin, and for octahedral, the pairing energy will be greater in high spin complexes. So in the question it is written high spin, then we have to take this one, means the pairing energy is greater. So the option will, the electrons will first fill in the T2G orbital, then it will go to the EG orbital instead of pairing up. Okay, because it requires greater energy to pair. So for D4, for D4, the 4 electrons will occupy like this. For EG, it has only 1 electron, so 0.6 into 1. And for T2G, it has 3 electrons, so 0 into 3. So the CFSE value comes out to be 0.6. Okay, so the first option will be correct. For question number 74. Okay. For question number 74, which of the following oxides exhibits neutrality? Okay, so neutrality, these oxides do not show a mark of, so all these are actually the neutral oxides. Okay, so the fourth one is correct, as it is a theory type question, or you can say it is a direct question. Okay, for question number 75, electrode potential for magnesium electrode varied accordingly to the equation. So the equation is given here. Okay, so first what we have to do, we have to equate this equation given. E mg plus 2 mg equals to E naught of mg plus 2 mg minus 0.059 by 2 log of 1 by mg plus 2. Okay, this equation is given. We have to change, we will change this minus sign by interchanging this. So see, here it is plus and the log comes at the numerator position. Okay, so like this we will find out, we will interchange this also. So what is the equation? E is equals to mx plus c, it happens. Okay, where what is c? C is the intercept. When c is the intercept, intercept is this one, E naught equals to mg plus 2 plus mg, and the slope is 0.059 by 2. So diagrammatically, what is the graph? This will be the graph. Okay, it will start from here in the option which is the correct one. In the option which is the correct one, option 2 is the correct one. Okay, this is the option number 2. So option 2 is the correct one. We have to just put in mind the equation for graph, okay, for intercept and slope. In question number 76, which of the following will not give the carbylamine test? So the carbylamine test, there are 3 options given and fourth one is none of these. So for carbylamine test, it is also known as the isocyanate test, and it is used to distinguish between primary, secondary and tertiary amines. So the primary amines react with chloroform like potassium hydroxide to form a foul smelling isocyanates. Okay. So the main point here is the primary amines give a positive carbylamine test. So among these, which is the primary amine? This is the primary amine, and if we will open this and write, then here CH3, CH3, H and NH2. Okay, so this is the secondary amine, and here C, NH2, CH3, CH3 and CH3. So this is the 3-degree amine. So among this is the primary amine, and primary amine only gives the carbylamine test. So first one is the correct option. For question number 77, which among the following demonstrate the cis-trans isomerism? Okay, so for cis-trans isomerism, the compound which shows the square planar geometry or octahedral geometry, these two will only show the cis-trans isomerism. So first we have to find all the geometries. Okay, so first option PTCl NH3 whole 3 whole positive. So this compound will follow the trigonal planar geometry. So it does not have a cis-trans isomerism. PTNH3 whole 4, it also has the tetrahedral geometry. Okay, so it also does not form the cis-trans isomerism. For PTCl4, this is an octahedral complex but with all 4 ligands being the same Cl. Okay, if there is the same Cl, then it does not show the possibility of like this. Okay, PT, Cl, 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 Cl. So how it will form the cis-trans isomerism? If two of the ligands will be same, then it can form the cis-trans isomerism even in octahedral compounds. So it is not possible in this case because all the 4 atoms are the same. Okay. For last option, which is the PTCl whole 2 NH3 whole 2. So this has the square planar complex and it is capable of showing the cis-trans isomerism. So see, this type of structure can be formed in the cis-trans isomerism. So option 4 will be the correct option. For 78, what will be the oxidation number of sulfur in the given structure? So we know that hydrogen has +1 oxidation state, oxygen has -2 oxidation state. The sulfur we have to find, so let's take it as X. Oxygen has -2 oxidation state and hydrogen has +1 oxidation state. Okay, so upon solving this, what we will get? X plus 1 -2 plus 1 equals to 0. So what we will get? X as +2. Okay, so the oxidation state of sulfur will be +2. Next is, which of the following will form the primary alcohol on reaction with Grignard reagent followed by hydrolysis? Okay, so 79, question number 79. This is the formaldehyde. This is B option is acetaldehyde. This is acetone. So formaldehyde on reaction, this is the formaldehyde. So formaldehyde on oxidation on reaction with Grignard's reagent, this type of structure is formed. Okay, it is OH. For acetaldehyde, this structure is formed, and for acetone, this structure is formed. So in the question it is given which of the following will form the primary alcohol. So among this, which is the primary? HCHO is the primary one. So option 1 will be, option A will be correct one. Okay, so for question number 80, select the correct sequence of reactions to carry out the following conversion. So this is the conversion, this is the reactant and this is the product. Okay, so let's see. For we have to use the NaBH4. So what does NaBH4 do? It reduces the ketone to 2-degree alcohol. Okay, so this ketone group will be reduced to secondary alcohol. Okay, it is secondary alcohol. Dibyl H, then dibyl H group is used. So what does dibyl H do? It reduces the aldehyde group. Okay, so this aldehyde group will be, it reduces to aldehyde group. So this compound will be reduced to aldehyde group. and then on heating and reaction with H3O, this OH will be taken out and this type of amine reaction is formed. Okay, so this is the product we have to form. Option 3 is the correct answer. We have to take these specific reagents. For option number 3, for question number 81, okay, sorry. For question number 81, for a first order reaction, the plot of log K against 1 by T is a straight line. The slope of the line is equal to. Okay, so log K is equals to log A minus EA by 2.303 RT. So we have to follow this equation. Y is equals to C minus mx. Here the slope is minus m. The slope is minus m. Okay, here it is minus m. It is the slope. And what is the slope here? This minus EA by 2.303 R3 303 R. So this will be the graph, and which of these is correct option here? Option 3 is the correct, minus EA by 2.303 R. Next is option number 82. For option number 82, identify the major product in the following reaction. So here pH C triple bond CH. In the presence of HgSO4 and H2SO4, it forms the product P. Okay. So what happens here? Here this triple bond, let us consider that this is a triple bond, and here okay, here, okay, this H plus H and OH, here it is H plus and here it is OH minus, and here let's consider it is positive sign and it is a negative sign. So what happens here? Okay, something is wrong here. It is, oh sorry, yeah. So for this it is positive, this carbon has positive charge and this carbon has negative charge. So what happens? The opposite charges will attract each other. The H plus will go towards this carbon and the OH minus will go towards this carbon. So this type of structure is formed. The C occupies the OH bond and the CH occupies the CH2. Here it will be CH2, which on tautomerization, what happens in tautomerization? This OH bond will this OH bond becomes C double bond O. Okay, so this type of structure, this H will be transferred here. This type of structure is formed. So which is the correct one? Option 3, pH C double bond O CH3. Option 3 is the correct one. For question number 83, the given reaction, it is a name reaction. We have to remember this name reaction. So which is the name reaction? It is the Gattermann reaction, or it is yeah, it is the Gattermann reaction. For question number 84, if the crystal field stabilization energy for the tetrahedral COCl4 whole 2 is 8000, what is the crystal field stabilization energy for the octahedral COCl4 COCl6 minus 4? Okay, so this is the equation that we have to remember. Delta T is equals to 4 by 9 delta T of octahedral one. Okay, so on substituting, what happens? Delta T, okay, this is the answer. Delta T is equals to 4 by 9 delta not octahedral, delta of octahedral. So delta T, which is given, crystal field stabilization energy for tetrahedral one is given as 8000. So tetrahedral it is 8000 and here it is 4 by 9 delta O. So 8000 into 9 by 4 comes out to be delta O, and the answer comes out to be 18,000. Okay. So answer is 18,000. Here, first one is the answer. Next is 85. Which statement accurately describes the characteristics of P4O10 molecule? Okay. The lone pair of phosphorus of the lone pair on each of the 4 phosphorus atoms forms a coordinate bond with an oxygen atom. Here. So each phosphorus atom has 3 unpaired electrons, okay, which means that it forms 3 covalent bond with other 3 phosphorus. Okay, let's explain it with the figure. This is the figure. Phosphorus has 3 unpaired electrons and it will form 3 covalent bond with other 3 phosphorus atoms. Okay, so this, if we consider this phosphorus, then it will form the 3 coordinate bonds, right? Here, here, and here with the 3 other phosphorus atoms. Okay, just a second. So first one is the wrong one. It contains 6 POP bonds. Okay. So number of POP bonds is 6. So this will be the correct option. Okay. So let's see the other options as well. It is followed by the hydrolysis of water forming H3PO3. So in this will be the hydrolysis. If we use the P4O10 and we undergo it as hydrolysis, then this structure H3PO4 will be formed and not H3PO3. So this is the also wrong answer. Wrong statement. Oxidation number of phosphorus in P4O10 is different from that of P in P2O5. If we find the oxidation state, then in both the cases it comes out to be +5. It is not different, so this option is also wrong, which means that the option second one is correct. Now come to section B. Oxidation, specific conductance of 0.1 molar HNO3 is 6.3 into 10 to the power minus 2 ohm inverse centimeter inverse. The molar conductivity of the solution is. So for finding the molar conductivity, we will use this equation. Delta M is equals to K into 1000 by C. Okay, where C is the molar concentration. So K, we will substitute the given value of K here. Okay, K is the specific conductance and C is the concentration. So upon putting all this, we will get the answer 630 ohm inverse centimeter square mole inverse. 630 ohm inverse centimeter square mole inverse. Okay. So for gas phase, what happens that the basic strength of amines is directly proportional to the inductive effect acting on it. Inductive effect, okay, directly proportional to the inductive effect. So let's find out which degree of amines are there. So this is the primary, this is first degree, this is the C2H5, this is the secondary amine, this is the tertiary amine, and this is the 0 degree amine. Okay, so the basic strength, tertiary amines will have the greatest basic strength, then secondary amine, then primary amine, then ammonia. Okay, which means that the tertiary amine will have the greatest basic strength, then secondary amine, then primary amine, then the 0 degree one. So which option will be the correct? C, C, then B, then A, then D. Okay, so first one is the correct option. Which species is the next question is question number 88. Which species is colorless? Okay, so for colorless, I have told that the orbital should not have any electrons, or it should be completely filled. Okay, so let's see for VCl3. For VCl3, the V is in the +3 oxidation state and it has 2 unpaired electrons. So it will be colored. For VO plus 2, it has the 4 oxidation state and 1 unpaired electron. It is also colored. For VO4, 3 minus, V5 plus has no unpaired electrons. Therefore, it will be colorless. And for the last VH2O whole 6 plus 2, it has 3 unpaired electrons. Okay, so the correct option will be third one, VO4 whole 3 minus. Okay, let's move on to the next question. Question number 89. Given below are two statements. Question number 89. Given below are two statements. The acidic strength of mono-substituted nitrophenol is higher than the phenol because of electron withdrawing nitro group. Statement 2 is the orthonitrophenol, metanitrophenol and paranitrophenol will have the same acidic strength as they have one nitro group attached to the phenol ring. Okay. So let's see, nitro group has the electron withdrawing tendency. For question number 89. So the nitro group has the electron withdrawing tendency, which means that it has both minus I effect and minus R effect. Okay. Thus acidic strength of mono-substituted phenol, nitrophenol is higher than that of phenol. So statement 1 is the correct one. Now nitrophenol present at ortho and para position will have the strong minus R effect. So the nitro group which is present at the ortho and para position. Okay, sorry. Here let's assume there is one R group. Okay, so here ortho, this is the ortho position, this is the para position and this is the meta position. So if it is at the ortho and para position, then they have the strong minus R effect. Here it is minus R and at para position also it is minus R. While if the nitro group will be at the meta position, then it will only have the minus I effect. Okay, so in this case, what will be the correct answer? Statement 1 is correct, but statement 2 is incorrect. So this will be the correct answer, option B. In question number 90, what is there? In question number 90, which of the following will undergo Cannizzaro reaction? Okay, so for Cannizzaro reaction, aldehydes having no alpha hydrogen. Okay, aldehyde which does not have any alpha hydrogen undergoes Cannizzaro reaction. All compounds other than benzaldehyde have a alpha hydrogen. So benzaldehyde, this type of structure is there, CHO. Okay, and acetaldehyde, which means CH3, CHO. Acetone is CH3, C double bond O, H, and pentanone is CH3, CH3, CH, CH2, CH2, C double bond O, CH3. Okay, so this is pentanone. So benzaldehyde is the only one which does not have any alpha hydrogen. Okay, so it will undergo Cannizzaro reaction. For question number 91, for question number 91, select the correct relation for the reaction 2A plus B tends to C. Okay, so for 2A plus B tends to C, this is the rate of reaction which is given minus 1 by 2 delta concentration of A delta T equals to minus delta concentration of B by delta T equals to delta concentration of C by delta T. So this is the rate of the reaction. So which is the correct option here? This. R is equals to R is equals to plus, here it is plus delta concentration of C by delta T. Okay, so this is the correct option. For question number 92, the melting point, the assertion is the melting point of para dichlorobenzene is greater than ortho dichlorobenzene. Okay, let's see. Here it is a benzene ring. Melting point of para dichlorobenzene. Okay, so this one is para dichlorobenzene is greater than ortho dichlorobenzene. Ortho, here it is Cl. Sorry. Okay, this is ortho dichlorobenzene. Okay, so these two structures are there. the melting point of para-dichloro. Okay, so this it is saying that this para-dichlorobenzene has high melting point than ortho-dichlorobenzene. Yes, it is the correct statement. So let's look at the reason here. Para-dichlorobenzene is more symmetric than ortho-dichlorobenzene. Okay, yes, this is the correct answer. This is the correct reason. See, it is a symmetric type molecule, right? If we draw the line of symmetry from the middle, if we draw the line of symmetry for the middle, so this is the symmetric molecule. So this is the correct option. So what will be the answer? Both assertion and reason are true, and the reason is the correct explanation for the assertion. Okay, option 1. For question number 93, the correct relationship between the pH of isomolar solution of sodium oxide pH 1, sodium sulfide pH 2, and sodium selenide and sodium telluride. These four are given. So what will be the pH? Let's see. Sodium hydroxide, then sodium hydroxide plus H2S. This is sodium oxide having pH 1. This is sodium sulfide having pH 2, NaOH plus H2Se. This is sodium selenide having pH 3, and this is NaOH plus H2T. This is sodium telluride having pH 4. Okay. So acidic strength, what will be the acidic strength? H2S will have the least acidic strength, then H2T, then H2Se, then this will be the acidic strength. So what will be the order of pH? We know that acidity, as the acidity increases, the pH value decreases, or it is inversely proportional. So the pH value will be lesser, which means that NaOH will have the highest pH value, then sodium sulfide, then sodium selenide, and then sodium telluride. So which is the correct option? Which is the correct option? Option 1. Option 1 here is the correct option. Okay. For question number 94. Given below are the half cell reactions. Mn plus 2 electrons give Mn. E naught is given here, and the second equation, and E naught is also given here. Okay. The E naught for 3 Mn plus 2 gives Mn plus 2 Mn plus 3, which will be okay. So the option are there. We have to multiply equation 2 by 2. So this is the equation 2. We have to multiply it by 2 and subtract it from equation 1. So we will get this. Similarly, we will find the E naught of the reaction. What will be E naught? The E of oxidation plus reduction, which comes out to be minus 2.69 volt. Negative value of EMF, which means that delta G is positive and show that the reaction is non-spontaneous. For reaction to be spontaneous, delta G have to be negative, but in this case as it is positive, so this is a non-spontaneous reaction, which means that the reaction will not occur. So option 1 is the correct one. Minus 2.69 is the value of E naught, and the reaction will not occur as delta G is equals to positive. Okay, so now question number 95. Which of the following amines will form a stable diazonium salt? Okay, so for stable diazonium salt, 1 degree aromatic amines forms stable diazonium salt. Okay, so see here it is 1 degree aliphatic amine. Okay, aliphatic amines. This is the 1 degree aromatic amine. Here it is also aliphatic amine because here one benzene ring is given, then it is CH2, then NH2. So it is the aliphatic one, and here it is the secondary, yani, which means that it is 2 degree aromatic amine. So among this, which is the 1 degree aromatic amine? Option 2. Option 2 is the correct option for this. So let's move on to the next question. What is the expected spin magnetic moment for the CO plus 3 ion? Okay. So for CO plus 3 ion, CO has the atomic number of 27, and for CO plus 3 it has the electronic configuration of 3d6. So what happens according to Hund's rule? 3d6 means this is the d orbitals, and 3d6 means 1, 2, 3, 4, 5 and 6. Okay, which means that how many unpaired electrons are there? 4. So 4 unpaired electrons are there. Let's put on the uh, formula for spin magnetic moment. So we know that magnetic moment is equals to magnetic moment. Sorry. Yeah. So magnetic moment follows the formula of root under n n plus 2, right? So we have 4 unpaired electrons, so n will be 4. 4 plus 2, which means that answer is 2 root 6 Bohr magneton. Okay, so second one is the correct option. Let's move on to the next question. Question number 97. Okay. So what happens in question number 97? This type of structure is given which on this is the cyclopentene, which on reaction with ozone this bond breaks and this type of structure is formed, which again on reaction with calcium hydroxide. What happens with reaction with calcium hydroxide? One molecule of water is removed and the calcium get linked up with these two carbonyl groups, okay, and follows this type of structure, which on again reaction on again heating. What happens after heating? CaCO3, okay, CaCO3, calcium carbonate is removed and this type of structure, which is the ketone, is formed. So what will be the option? B. B is the correct option. Let's move on to the next question. Question number 98. A complex compound where the metal has the oxidation number of 0. So the metal oxidation number of metal, in which of these the oxidation number of metal is 0? The answer will be FeCO whole 5. In all the other cases, the oxidation number is not 0. Okay. We can write this also as FeCN whole 6 minus 4. Okay. Okay, let's calculate it one by one. Fe is x and it is 6 into minus 1 equals to minus 4. X is equals to minus 6 minus 4, then x is equals to minus 4 plus 6, which comes out to be plus 2. For second K3FeCN whole 6, this can be written as FeCN whole 6 minus 3. Fe, let Fe be X, and it is Cn has plus -1 oxidation state, and it is -3. So X equals to -3 plus 6, which is +3. Okay. In this case also, Fe F6 -3. Fe is X, and it is -6 -3. Then it comes out to be +3. Only in the case of FeCO whole 5, the oxidation state of CO is 0. So X plus 0 is equals to 0, which means that 3 is the one option which has the oxidation state of 0. Okay. For question number 99. For question number 99, the product PHC triple bond CH in the presence of dilute H2SO4 and HgSO4 gives the product A, which on reaction with benzaldehyde and heat gives the reaction B. So here PHC triple bond CH in the presence of dilute H2SO4 give a product this. Okay. Then again on reaction with benzaldehyde gives the product this. Here it is pH, and on heating we will get this compound. Okay. So what is this compound? It is 1,3-diphenyl. Yeah, it is 1,3-diphenyl prop 2 in 1 on. Okay. So the last question of chemistry. The formation of PH4 plus is difficult as compared to NH4 plus because, okay, so the formation is difficult because lone pair of phosphorus reside is in almost pure s orbital. So here it is one mistake that the answer given here is 2. So 2 is not the correct option. Option 4 will be the correct option, as the lone pair of phosphorus reside is almost pure p orbital. So this is the correct option. Okay. So due to this, what happens? The phosphine lacks the nucleophilicity, and the donation of lone pair of protons become difficult. So in ammonia, lone pair is present in sp3 orbitals. Okay, it is present in sp3 orbitals. Lone pair of, in ammonia it is written, and here it is phosphorus. So this option will be incorrect, and it can be easily donated to protons. So all the four are incorrect, 3 are incorrect, and option 4 will be the correct answer. Okay. So thank you.